Hi there. Let's go over some of the problems that are on our test prep. Most of these problems came from the quizzes. There are three versions of the quiz, so what you'll see for each of these is three problems that are fairly similar to each other. So number one, your directions are to factor. So since a equals 1, we're going to do regular big X. And remember, when a equals 1, do the big X, find the factors, almost done. So we are going to do a times c on top, which gives us 18 positive, and a negative 11. Remember, b goes on the bottom. We're looking for numbers that multiply to be 18 and add to be negative 11. Since we have a negative on the bottom and a positive product, then we know that both of these have to be negative. The only way to get a positive product is a negative times a negative, or a positive times a positive. So 18 can either be 1 times 18, 2 times 9, or 3 times 6. So 2 times 9 is the one that's going to work. So I have 9, 2. I double check myself. Is negative 9 times negative 2 positive 18? Yes. Negative 9 added to negative 2 is negative 11? Yes. And so now I write my factors. Remember, I'm supposed to solve, so I have 0 equals x minus 9 times x minus 2. And now I'm going to split into two problems to solve this. And for camera reasons, I'm going to put this up here. X minus 9 equals 0. And the 0 could be on either side. And x minus 2 equals 0. I'm going to solve this one first. To isolate x, I need to add 9 to both sides of the equation. X equals 9. Add 2 to both sides of the equation. X equals 2. These are my solutions. If I had time, I would plug these in individually into this equation, and I would find out if I put a 9 in for x when I evaluated it, this side would indeed equal 0. If I plugged in a 2 for x and evaluated this side, it would also equal 0. Okay, on to 1b. A times c goes on top, and that in this case is 1 times 20, which is 20. And b always goes on the bottom, negative 12, b for bottom. I need a product of 20 and a sum of negative 12. Because I have a positive product, I either have to have negative negative or positive positive. It's going to have to be negative negative because b is negative. Well, 20 can be 1 times 20, 2 times 10, 4 times 5, or 5 times 4. That's about all you have there. So out of these, the 10 times 2 is what's going to work best. Now, because a equals 1, I don't have to do factor by grouping. I do the big X, I write the factors, and then I'm almost done. So I'll write my factors over here. 0 equals, because remember I'm solving, x minus 10 times x minus 2. I need to set each factor equal to 0. Most people prefer to write the equal 0 on the right side, but it really doesn't matter. Now to solve this, I need to isolate x, use inverse operations. So here I'm going to add 10 to both sides. Of course, 10 minus 10 is 0, so I get x equals 10. Here I add 2 to both sides because I want to eliminate the 2 that's over here with the x. Negative 2 plus 2 is 0, that's what I wanted, and x equals positive 2. If I took the time to substitute positive 10 into my original equation, I would find that this side ended up equaling 0. If I had the time to substitute 2 into my equation, I would find that this side, when a 2 is substituted, equals 0. Okay, another one where a equals 1, and we're supposed to solve. A times c goes in the top, that would be 24, and b goes in the bottom, and I notice I have a negative 14. Now, because I have a positive on top and a negative on the bottom, I have a positive product, and that can only be negative negative, negative times a negative, or positive times a positive. But because I have a negative 14 here from my sum, I know these have to be negative. 24 has quite a few options. 1 times 24, 2 times 12, 3 times 8, 4 times 6. So which of these will give us a sum of 14 if they were both negative? That would be that one. So I'll do 12 and 2. Remember when a is 1, do the big X, write your factors, almost done. So here are my factors, x minus 12, x minus 2 equal to 0, because they told us to solve and they gave us an equal 0. Now I'm going to set each individual factor equal to 0. And here I go. I'm going to isolate x by doing the additive inverse. Negative 12 plus positive 12 is 0. And that means I just have an x left on this side. And over here I would have a positive 12. I want to get rid of this negative 2. So I'm going to do the inverse. I'm going to do that on the other side also. And I get x equals 2. So these are my solutions. If I were to substitute the 12 into the original equation and evaluate it, I would get 0 on this side. If I were to plug the 2 into this original equation and evaluate it, I would get a 0 also. These are the values of x that make this equation true. All right, let's move on to number 2. And for number 2, we are supposed to solve by factoring. And so I notice here that my a equals 12. So that means I'm going to have to do special big X, which means I'm going to have to include factor by grouping. Okay, so this one has a few extra lines of work. So on the top of our big X, remember that it's a times c. So that's 12 times negative 3, which will get me negative 36. The bottom is negative 5, B for bottom. Now I need two numbers whose product is negative 36 and whose sum is negative 5. Well, I'm going to put a negative and a positive because the only way I get a negative product is a negative times a positive. Now you can switch this positive and negative. What I always do is I always put whatever the sign of B is, I always put that one here. And then what's going to happen is if I put the bigger number here, my addition and subtraction is going to be correct. I won't accidentally switch my signs. So let's think about things that multiply to be 36 because there are certainly a lot of them. 36 times 1, well, no way that that is going to have a difference of 5. If I divide 36 by 2, I would get 18 and 2. Well, 18 minus 2 is not going to get us 5. And then if I divide by 3, I would get 12 and 3. And a negative 12 plus 3 is not negative 5. And then let's see, 4, that's a times table. That gives me 9 and 4. Negative 9 times 4 is indeed negative 36. And if this were a negative 9 and a positive 4, I would get negative 5. Now, I cannot say that my factors are x minus 9 and x plus 4. That won't work, okay? I have to do my bring down step here. So I'm going to bring down my 0 equals, and then 12x squared. I keep that term. I'm also going to bring down this minus 3. And now, see this negative 5x? It gets split, and the negative 5x is now written instead as negative 9x plus 4x. This equation is the same as my original equation. I have simply split up the b term, and that's what big X did for us. Now I have to look for the greatest common factor in the first two terms and then the second two terms. I look at my greatest common factor between 12x squared and negative 9x. First thing I notice is they both have an x, so I know I could factor out an x. I notice that they also both can be divided by 3. So I factor out 3x. 12x squared divided by 3x is 4x. Another way to think of that is 3x times blank would get us back to 12x squared. Well, 3x times 4x would take us back to 12x squared. Then negative 9x divided by 3x is negative 3. Now, if you did this right, if you were to distribute this 3x, it would take you right back to here. Now, we always bring down this sign, so I'm going to put a plus sign here. 4x and negative 3, their greatest common factor is 1. So then I'm just going to easily write 4x minus 3 here. We like when that happens. Put my 0 here. And now the next step is, technically I'm factoring out a 4x minus 3, but the way I've shown y'all to do it is simply to take this 3x plus 1 and make it into a binomial, that is, put it in parentheses as a factor, and take the 4x minus 3 and keep that as the other factor. Admittedly, I'm skipping a little bit of information there, but again, we take this 3x plus 1, make it into our first binomial factor, and then we keep the 4x minus 3 as our second binomial factor. And you're not quite done, because you're supposed to solve for x, which means I now need my zero product property, and I'm going to say 3x plus 1 equals 0, or 4x minus 3 has to equal 0. Over here, I want to isolate x, so the first thing I'm going to do is get rid of that pesky 1. If I want to get rid of adding 1, I need to subtract 1. Positive 1 and negative 1 make 0. So I have 3x equals negative 1. But I don't want 3x, I only want 1x. So let's divide that up by 3. 3 divided by 3 gets me just 1x. We always just write that as x. And my answer is negative 1/3. And you should expect on these kind of problems to get at least one fraction answer, and often two fraction answers. Okay, and over here, if I want to get rid of this minus 3 to isolate x, I add 3 to both sides of the equal sign. I get 4x equals 3, divide by 4, divide by 4, and now I'm down to 1x equals positive 3 over 4. And those are my solutions. If I wanted to substitute negative 1/3 into this original equation and do all the work, I would get 0. If I plugged in positive 3 over 4 into this original equation and did all the work, I would get 0. Okay, 2b. So again, we see, because a is not 1, that we're going to do special big X, which is factor by grouping. A times c goes on top, that's negative 36. B goes on the bottom, that's negative 5. Interestingly, this problem actually works out similarly to the last problem, in that we end up with a negative 9 and a 4 here. And it doesn't continue that way, though, because when we do the bring down step, things are a little bit different. Okay, so just like the other problem, we can use this negative 36. A negative 9 times a positive 4 gets me negative 5. So now my bring down step, bring down my 0. I bring down my 9x squared, and I bring down my negative 4. Instead of bringing down negative 5x, I'm going to bring down negative 9x plus 4x. Negative 9x plus 4x is the same thing as negative 5x. So this equation here is the same as the equation above. All I've done is I've rewritten the b term as negative 9x plus 4x. So now I look for the greatest common factor between the first two terms. Well, the greatest common factor between 9 and 9 is indeed 9. And in fact, it's 9x, because both terms have an x. 9x squared divided by 9 gets you simply x. Negative 9x divided by 9x gets you negative 1. I bring down this sign, which is a positive. And 4x and 4 have a common factor of 4. And 4x divided by 4 is x. Negative 4 divided by 4 is negative 1. Now, if you ever do this and these two binomials don't match, then either you had a mistake here, or what often happens is, like, I saw some people factored out a 3x here, and if they had done that, then these two binomials wouldn't have matched. And so another thing to look for if these don't match, besides looking back at your original big X, is make sure you really took out the greatest common factor. Okay, and now I'm ready to group these. And so what I'll do is, really I'm factoring out an x minus 1, but how I've shown you to do it is just to take the 9x plus 4, the numbers that are not inside the parentheses right now, and make them into their own binomial factor, and then take these matching binomials, x minus 1, and write that one time as the other factor. If I multiplied these back together, did all the distribution, take me back to here. But I'm supposed to solve, so I have a little bit of work left to do. I'm going to take each factor and set it equal to 0. So here I have 9x plus 4 equals 0, and x minus 1 equals 0. If I want to isolate the 9x, I subtract 4 from both sides, and I have 9x equals negative 4. But I don't want 9x, I want 1x. That's 9 times x. The inverse is to divide. Divide there. And now I have 1x equals negative 4 over 9. Over here, I want to isolate the x, so I add 1 to both sides. Negative 1 plus 1 is 0. That's what I wanted. So now I have just an x over here, and x equals 1. So these are my solutions. Okay, one more of these. And again, these three problems are all very similar. And that was because there were 3 versions of the quiz, and I wanted to make all 3 versions of the quiz as equal as possible, or as equal in difficulty as possible. So on this one, when you do a times c, once again you get negative 36. Once again you get negative 5, and once again the answers that are the sides here were negative 9 and 4. So actually every single person's quiz had this special big X in it, but what happened afterwards was a little bit different. So here I bring down my 0 and my equals 6x squared, then minus 9x plus 4x, and then I bring down that minus 6. I'm looking for the greatest common factor in the first 2 terms, and what I get there is 3x, because both of these terms can be divided by 3, and they can divide by x. 6x squared divided by 3x is 2x. Negative 9x divided by 3x is negative 3. I bring down this sign, in this case it's a positive. And what's the greatest common factor between 4x and negative 6? That's going to be 2. 4x divided by 2 is 2x. Negative 6 divided by 2 is negative 3. Then I set each of these, or I take the 3x plus 2 and give it its own binomial. I took that 3x and that 2. And then I take the 2x minus 3. That's already in the binomials, and I use that. Then I'm going to set each of these factors equal to 0. I get 0 equals 3x plus 2. Actually, I'm going to rewrite that. Most people like the 0 on that side, so I'll do it like that. And 2x minus 3 equals 0. I need to isolate x, so I'm going to subtract 2 from both sides here, because that's the inverse operation. I get 3x equals negative 2. That's 3 times x. Then the inverse of that is of dividing by 3. And here I get x equals negative 2 over 3. That's one of my solutions. Over here now, I'm going to add 3 to both sides. 2x equals 3. Divide both sides by 2 to isolate x, and x equals 3 over 2. So those are my 2 solutions. Of course, as usual, I would encourage you to try to do these problems again without the assistance from the video, because just taking notes from the video might help you through some bumpy spots, but it doesn't guarantee that you have independence on these. So please remember to try the problems again on your own. Okay, quadratic formula 3a. So this was what we were given, and you need to identify your a is 3, your b is 7, and your c is 4. In this case, they're all positives. Then it's always a good idea to write out your quadratic formula from memory. Make sure you have it. And now we fill in. B is positive 7 up here, so it'll be negative 7 here, plus or minus b squared, that's 7 times 7, minus 4 times a, which is 3, times c, which is 4, all over 6. So 4 times 3 is 12, times 4 is 48. So I have minus 48 up here. 49 minus 48 is going to give me a discriminant of 1. Now, because 1 is a perfect square, I have a little bit more work to do. This is going to be negative 7 plus or minus square root of 1 is just the number 1 over 6. Still not done. I have two solutions happening now. One of them is negative 7 plus 1 over 6. That's going to equal x. And the other one is negative 7 minus 1 over 6. Now notice the negative 7 never changes. This whole time we kept a negative 7. The plus and minus only affects the number under the root sign. And now this is like a fraction problem. Negative 7 plus 1 is negative 6 over 6. And negative 6 divided by 6 is negative 1 equals x. So this one had a whole number solution. Over here, I have negative 8 over 6. That equals x. I can simplify that by dividing top and bottom by 2. And that gives me negative 4 over 3 equals x. Okay, I saw a lot of people make this into a mixed number. You don't have to do that. You simply have to make the fraction have its simplest form, meaning you've divided out the common factors, and you can stop there. Of course, I would encourage you to try the next two problems on your own and just use this recording to check your work. And again, these next two problems are very similar to this one that we just did. Oops, ignore that. 0 equals 0. All right, here's our next problem. A, B, and C are all positive numbers. And I wrote my quadratic formula out again. Negative b is negative 5. B squared, 25, minus 4 times a times c, all over 2a, which in this case is 2 times 2. So negative 4 times 2 is negative 8 times 2. This is going to be a negative 16. 25 minus 16. Well, that equals 9. So what we're going to do is we're going to look at this and say, hey, 9 is a perfect square, in which case I can actually continue to work on this. So I have negative 5 plus and minus 3, because the square root of 9 is 3, over 4. And now I'm going to split this into two answers. X equals negative 5 plus 3 over 4, and x equals negative 5 minus 3 over 4. And I'd like you to notice that the negative 5 remains for the entire problem. The plus and minus only affects the 3. Okay, negative 5 plus 3 equals negative 2 over 4. And that simplifies a little bit more into negative 1 over 2. Negative 5 minus 3 over 4 equals negative 8 over 4. And that simplifies a little bit further to negative 2. So those are my two solutions. And here's our last one. Again, all positive a, b, and c. Negative 8, b squared is 64. Minus 4 times 7 times 1, that's going to be minus 28. And then if I do 64 minus 28, that gets me 36. Negative 8 plus and minus, well, the square root of 36 is the number 6 over 14. And that's going to equal, x equals negative 8 plus 6 over 14, and x equals negative 8 minus 6 over 14. In this case, negative 8 plus 6 is negative 2 over 14. That simplifies by dividing top and bottom by 2 to negative 1/7. Over here, I get negative 14 over 14, which simplifies to negative 1. Okay, moving on. We have some more quadratic formula problems. Again, I want to encourage you to try these problems on your own first, or do one with me and then try the other ones on your own. I think there's only limited benefit if you are just copying off the video. Okay, so here I have a equals 1, right? There's an invisible 1 here. B equals -9, and C equals -2. So I'm going to have to be careful with my A, B, and C. If I'm going to put negative B in here, that means -9, -1 times -9. So it becomes a positive. If you have a negative B here, then -9 is +9. Okay, or most people just think of it as switch the sign. Plus or minus, square root. And by the way, if you square -9, you get +81. If you square any number, you get a positive. Minus 4 times A times C, which is a -2. Well, -4 times 1 is -4. -4 times -2 is +8. Okay, so if you have two negatives over here, you're going to turn it into a positive. So now I have 81 plus 8. Well, that's 89. And 89 does not have a perfect square. So I'm going to have 9 plus 89 over 2 and 9 minus 89 over 2. Those are my two solutions. Okay, here on 4b, a equals 1, b equals -3, c equals -5. I notice I have some negatives here. I'm going to have to be really careful. Negative b means b times -1 or the opposite sign of b. So a -3 turns into a +3. Then b squared, well, -3 times -3 is +9. 4 times a, which is 1, times c, which is -5. So look, -4 times 1 is -4. -4 times -5 is +20. So I'm going to have 9 plus 20. And 2 times 1 on the bottom. So then I have 3 over square root of 29, or 3 plus or minus square root of 29 over 2. 29 doesn't have a perfect square root. In fact, it can't simplify at all. So I have to keep that square root sign. So I have 3 plus root 29 over 2 and 3 minus root 29 over 2. For some reason on our exam, I saw students when they went from this step to here, for some reason they just erased the square root sign. But I want you to remember that the square root of 29, if you put it in a calculator, it would get you 5 point something. That is not the same as the number 29. So 3 plus square root 29, 3 minus square root 29. You got to keep that square root sign unless it's a perfect square. Okay, last one of these. A equals 1, B equals -5, C equals -3. I've got negatives here, so I have to be careful. Negative B, which is like -1 times -5, gets me +5. You can also just think of switching the sign. If I have a negative number here, it'll be positive when I put it in the beginning of the quadratic formula. Plus and minus, B squared, well, -5 squared is +25. Minus 4 times A times C. Notice I have a -4 and a -3. This is going to end up being a +12. So 25 plus 12. That equals 37. There is no perfect square root of 37. So my answer ends up being 5 plus square root 37. Notice I'm keeping the square root. 5 minus square root 37. Both of those are over 2. And those are your answers, and they're in most exact form. You can't simplify them any further. If you had to graph them, you could put them in a calculator and use the calculator to get you a decimal answer that you could graph. Woo, that was all the quadratic formula problems. Now it's time to simplify some square roots. So something we have to know when we're simplifying square roots is that our answer choices for the first number in the square roots have to come from the list of perfect squares. 4 is a perfect square, it's 2 times 2. 9 is 3 times 3, 4 times 4, 5 times 5, 6 times 6, etc. So the idea of simplifying a root is that if you can rewrite the radicand as the product of a perfect square and some other number, then you'll be able to simplify part of it. So for example, 44, that's 4 times 11. 4 is on this list. That's really great. So I'm going to put a 4 here, and an 11. Now notice root 4 times root 11 is root 44. I really haven't changed the problem, I've just broken it up a little bit. Then the square root of 4 is just plain old 2. The square root of 11 is an irrational number, and it can't be simplified further, so it just stays like that. Okay, 6a, square root of 99. Well, if I look here, are any of these numbers factors of 99? 9 is, because 99 can be rewritten as square root of 99 can be rewritten as square root of 9 times square root of 11. The square root of 9 is 3. The square root of 11 is the square root of 11. It's an irrational number. So that's my final answer right there. Now, when we get to 76, you might look at this list of numbers and think, first of all, I can't think of any times table that has an answer of 76. You know, we have 9 times 8 is 72. 7 times 7 is, 7 times 10 is 70. 7 times 11 is 77. 76 doesn't pop right into my mind. So the thing to do here is you can start dividing by each of these numbers, or you can make a factor tree. I just divided 76 divided by 2, and I got 38. And then 38 divided by 2 got me 19. And so look, 76 can be written as 2 times 19. Well, 2 times 2 is the perfect square 4. So I found it. Find a pair, you found your square. So I can rewrite this as 4 and 19. Square root of 4 is 2. Square root of 19 is an irrational number, so I just keep it like that. Okay, the other thing you could have done instead of a factor tree, if you wanted, was say, I think 4 might go into 76. 9 isn't, because 7 plus 6 is 13, so that eliminates the 9. I don't know about 16. I know 25 doesn't work. I should know that 36 times 2 is 72, so that's not going to work. So if I wanted, I could have just divided 76 by 4. Okay, let's look at the B row. So here we go. We have square root of 40. Where I look at this list, and 4 is going to work. You know, you always want to consider if 16 is going to work, but it doesn't work in this case. So I'm going to have square root of 4 times square root of 10. Because square root of 4 times square root of 10 is square root of 40. Square root of 4 simplifies to the number 2. Look, it's an integer without a root. Square root of 10 cannot simplify. Now, can the square root of 10 simplify further? Well, it is 2 times 5, but that doesn't really help us because the square root of 2 doesn't turn into anything. It's an irrational number. And the square root of 5 doesn't simplify into anything. Only these numbers simplify to be an integer. So this is as far as we can go. 6b, sorry, I butchered this a little bit. It should have been square root of 27. So we look at this list, and yeah, 9 is a factor of 27. In fact, it's 9 times 3. So I have square root of 9 times square root of 3. Well, the square root of 9 is the integer 9, is the integer 3. And the square root of 3 is an irrational number, and it just stays like that. Okay, 84 is another one of those numbers that is not an answer to a times table. So you might have started off by just seeing if 4 works. That's a good solution. You know that 9 is not going to work because 8 plus 4 is 12. And if you just did the divide by 2 method, you would get 2 times 42. 42 is 6 times 7. And then you could take your factor tree all the way down. And at the bottom, you would have 2 times 2. There's your perfect square, right? Because 2 times 2 is 4. Then let's put these together, times 21. So I have 4 times 21. There's my perfect square and my other number. So I can rewrite this as 4 times 21. Square root of 4 is 2. Square root of 21 is irrational, and it goes like that. Now again, these problems are very similar. They're because, again, they came from 3 different quizzes. So these 9 problems are actually quite similar to each other. And I'm saying that because please, just because you could do these 9, you might not be ready to do everything. Make sure you do the other part of this assignment, and you also go back and look at all those problems we had when we were first learning square roots. I think we had 2 pages of these. Okay, square root of 28. Well, that is 4 times 7. Square root of 4 times square root of 7 is a square root of 28. 4 simplifies, and you get 2 square root of 7. 63. Well, I look at my list, and I know that 9 is a factor of 63. And 6 plus 3 is 9, so that helps me know that. Square root of 9 is 3. Square root of 7 is an irrational number, square root of 7. Okay, 52. It's not the answer to any of our times tables. I mean, 10 times 5 is 50. 11 times 5 is 55. 7 times 8 is 56. And 9 times 6 is 54. But nothing lands on 52. So I could say, well, I could divide 52 divided by 4. That would be a good way to start. Or I could do the factor tree. I figured out that 52 is 2 times 26. 26 is 2 times 13. Here's my pair. So I can say that 52 can also be written as 4 times 13. 52 is the square root of 4 times 13, square root of 13. Square root of 4 simplifies to be the number 2. Square root of 13 is irrational, and it stays that way. Okay, also, as you could tell from this, if you're not brushed up on your times tables, this gets a lot more difficult. So one of the things you can do to help prepare for simplifying square roots is to make sure that you have practiced your times tables on a regular basis so that you're pretty quick with the dividing. We've also talked about how having this skill of simple long division is also important. So that's something you should review if you've forgotten how to do that. Okay, I hope this video has been helpful, and hopefully there aren't too many mistakes because I did it in one take. So hoping for the best. Man, it better have recorded. Have a great day and good luck on your exam.